Myself, Dr. P.P. Wani from Gokhale Education Society's R.S. Sapat College of Engineering, Management Studies and Research, Nasik, welcome you all on video lecture series for instrumental methods of analysis. From this video, we are able to learn what is pH metry, how can you measure the endpoint for a strong acid, strong base titration using measurement of pH. You know that pH of the solution is nothing but negative logarithm to the base concentration of H plus ion. That is called as the pH. So for that we required some terms to learn the pH metry. That is, first is called as the buffer solution. That is, we say that the solution which resists or opposes the change in pH of the solution on addition of small acid or a base. That is called as the buffer solution. That is, when this buffer solution is present, it opposes the change in the pH of the solution, either addition of acid or a base into that solution. That solution is called as a buffer solution. From that Henderson's equation, buffer solutions can be prepared as a pH of acidic buffer, that is pKa is equal to log of concentration of salt upon concentration of weak acid, and pH of basic buffer is measured by using pKb plus log of concentration of salt upon concentration of a weak base. That is the solution, or that is the formula for preparation of pH of the acidic buffer as well as basic buffer. So how this acidic buffer is formed? Acidic buffer is formed, that is weak acid and its salt with the strong base. For example, when you take that weak acid as an acidic acid, so what is the salt of that acetic acid with its strong base? For example, when we say that weak acid CH3COH acetic acid and strong base, that is CH3COH plus NaOH, when react with each other, it form sodium acetate. This sodium acetate is called as a salt of that weak acid with strong base. When this weak acid and whatever salt is formed by reacting that weak acid with the strong base, I think CH3CONA, means combination of both of these, that is CH3COH plus salt of weak acid and its reaction with the strong base, I think CH3CONA, this is called as a acidic buffer. Means acidic buffer are formed by weak acid and its salt with the strong base. In opposite case, that is in case of basic buffer, this buffer solution, that is basic buffer, are formed by weak base and its salt with the strong acid. For example, when you take the weak base as a ammonium hydroxide, that reaction of ammonium hydroxide with the strong acid, that is HCl, that is NH4OH plus HCl, then it form NH4Cl as a salt of weak base and it salt with the strong acid. When this combine with each other, that is NH4Cl plus NH4OH, I think whatever buffer solution is formed, we called as a basic buffer. For learning this pH metry, we require to know the concept of buffer solution and how this acidic buffer and basic buffer are formed. So for measurement of endpoint for this titration, we require to standardize the pH meter. What do you mean by standardization? Standardization is nothing but when we take the solution of a particular known pH, that pH meter will show the same pH, but sometimes it shows a somewhat plus minus pH, so that's why you will have to adjust the pH on the same by using a standardized knob. So how this process is carried out for standardization of pH meter? That is, first do the connection for the pH meter to the electricity. These are the simple steps. Clean the electrodes and connect the electrodes to the pH meter. Adjust the temperature knob at 25. We say that 25 degrees centigrade temperature as a normal temperature. Then immerse the electrode into the known pH solution. If the pH reading on the pH meter shows a different reading than known pH, then adjust the standardized knob of the pH meter to show the known exact pH. For example, when we take the solution of pH 4 and when it shows the pH 4.2, then by using the standardized knob, adjust the pH to 4. And when this adjusts the pH 4, we say that this pH meter is standardized. And when we standardize the pH, the remaining reading, you will get the correct reading. That's why we require to standardize the pH meter before starting the experiment for measurement of pH of the solution every time. So in this we have to learn strong acid versus strong base titration using measurement of pH. See here, in this both acid as well as base are strong, that's why dissociation will take place 100%. Then how this reaction takes place, that is simple reaction. I think everybody knows that HCl plus NaOH, it forms that NaCl and H2O. No problem for the reaction. I think everybody can learn this reaction very easily. But we are interested in the graph. That is, see here, we will have to require to plot a graph of ml of base added against pH of the solution. Means when we plot the graph of ml of base added, that base should be in a burette, and measure the pH of the solution. See here, base is added means acid is present in the beaker, means take a suitable quantity of acid in the beaker. When you take suitable quantity of acid in the beaker, start addition of base from the burette. When you start addition of base from the burette, initially as you take the acid in the beaker, initially pH is low. When you start adding the base into it start increases, but at certain extent it will start increases by addition of a base. When endpoint has been reached, that is, suppose we say that after each addition, that is small quantity of base from the burette, generally 0.5 ml or 1 ml is preferred to know addition of change in a pH of the solution by addition of that base. So when you start adding base from the burette, then pH start increases. When pH start increases, and endpoint has been reached, instead of change of pH, that is small change in a pH, drastic change in a pH takes place. And when drastic change in a pH takes place, indicates that endpoint has been reached, and after endpoint the pH remains constant. After endpoint, near about pH remains constant. So that pH remains constant because 100% neutralization of acid will take place by addition of that base. That is the explanation for nature of this graph. And what is the procedure that just I have told you, that is pipette out the known quantity of HCl in a beaker, immerse the indicator, we say that electrode used as a glass electrode and reference electrode as a calomel electrode, but nowadays a combined electrode is available and this is used as a pH electrode. Fill the burette with 0.1 normal NaOH solution at 0.5 ml of NaOH, that is base, to the acid in the beaker and stir the solution. Measure the pH. Continue the addition of 0.5 ml of NaOH and note the pH after every addition of NaOH till sudden increase in pH of the solution is observed. Then continue addition of 0.5 ml of NaOH, pH remains constant. The nature of the graph is shown, just I have explained in a previous slide. So thank you very much for your patience listening. I think from this video you will able to learn how pH measurement takes place, what is the end point for this titration, and how can we measure the end point for the strong acid strong base titration using pH meter or measurement of pH. So thank you very much for your patience listening.